Hello and welcome to the session on Pandas. Pandas is an open source library that is used to analyze data in Python. It provides high performance data manipulation and analysis tools using its powerful data structures. Just like NumPy, Pandas has its own data structure called DataFrame. DataFrame can store values in a tabular format with rows and columns. Pandas library could be used to create a data frame directly from a CSV file or an SQL database. The key features of Pandas libraries are fast and efficient data frame object with the default and customized indexing, tools for loading data into in-memory data objects from different file formats, data alignment and integrated handling of missing data, reshaping and pivoting of datasets is also very simple using Pandas, label-based slicing, indexing and subsetting of large datasets help access data smoothly, mutable data structure for an easy add, delete and update facilities, even deleting or merging of columns is easier, group by functionality for data aggregations and transformations, high performance merging and joining of data, direct data plotting, and functionality to handle time series. The main advantage of Pandas is that it can hold and operate on mixed data such as an inventory list for a retail giant, which contains timestamps, prices, quantity, name, and descriptions over thousands of different items. In this session, we'll start with the basic fundamentals of Pandas through various demonstrations to learn and implement the functionalities available. Then in the latter half of the session, we will concentrate on analyzing a real-world dataset which would help an FMGC client take better decisions. In this part of the course, we will be introduced to Pandas library. It's an open source library with powerful data structures and high performance data manipulation capabilities. One of the very useful data structures in the Pandas library is the so-called data frame. It is a two-dimensional tabular data object with rows and columns, very much like an Excel file or a CSV file or an SQL table. With data frames, columns are attributes, and each column holds same type of information, and rows are actually the information. In the first example of this course, let's create a data frame using raw data stored in a dictionary. For that, we have to import Pandas library as PD, which is the short for Pandas. We have three sets of data stored in list. We have list of countries, United States, Australia, Japan, India, Russia, Morocco, and Egypt. We have a Boolean list indicating whether drivers drive in the right side of the roads in those countries. And we have the number of cars per cap, which is the number of cars per 1,000 people, which is 809 for United States, 735 in Australia, and so on and so forth. So this is the raw data for now, which is stored in list, and we want to create a data frame from that. In order to create a data frame from these three data, we have to first create a dictionary. The dictionary would look like something like this. It's a dictionary, we call it data. It has three keys, and I'm gonna name the keys the same as the number of this list. You can create any name that you want, but we need three keys. The first key is the car per cap. The value corresponding to that key is actually the exact list, which is cars per cap. So for now, we have created one key and its value. The second key would be the name, the country, and the value would be the list of the countries that we have. The third key of this dictionary data is drive underscore right, and the corresponding value would be the list of Boolean values indicating whether drivers drive in the right side of the roads or not. Right, so this is our dictionary. For the sake of sanity check, I'm just going to print the data, and as you can see, it's a dictionary. So we have three keys: cars per cap, country, and drives right, and we have three values for each key. The values are list coming from the list stored in block 9 of the code. So far, we have created dictionary. How do we go from a dictionary to a data frame? That's actually a very simple line of code. I'm going to create a variable called cars. I'm going to call the PD, which is the Panda library for FaceTime, and within that library, I'm going to call DataFrame. So DataFrame is a method or function under Pandas library. Inside parentheses, you have to type the name of the dictionary in which you have stored the data. If you do so, and then you print cars, you're going to see that two-dimensional tabular data that we talked about. It looks like a CSV file. You have columns and you have rows. The rows are the actual data, and the columns are the attributes. The values in each column are the same type. So we have integers under the column cars per cap. We have strings, name of the countries, under the column country, and we have booleans under drives right. Let's see what is the type of cars variable. So if I get type cars, it's going to tell me that it's a data frame. It has more to that, but for now we can simply assume that this is a data frame, which actually it is a data frame. So with this, we have created our first data frame using the data stored in a dictionary, which has keys and values. We got the values from the list that initially we had stored data. So again, this is a data frame. The name of the data frame is cars. It consists of multiple rows corresponding to the actual data that you have. So you can see that the data stored in the first row is actually the number of cars per cap for the country United States, and indicating whether people drive in the right side of the roads in that country or not. So if you pull out the data in the first row, or row number of if you pull out the data in row 0, you actually have all the data you need for the country United States, whether drivers drive in the right side of the road, and also the number of cars per cap. In the first example, we created our first data frame using raw data stored in a dictionary. In the next example, we are looking into another way of creating a data frame. One very typical way of creating a data frame is to import data from a CSV or an Excel file. So we are basically reading data from a file and creating a data frame from that data. To do so, we have access to a CSV file called cars.csv, and we are going to read that file and create this data frame. I'm naming the data frame cars_df, pd, read, and you see here we have different functions under Pandas library to read CSV file or an Excel file if need be. I'm going to use read_csv and call this CSV file. And let me print the content of this data frame. So when I do so, I get all the content that was stored in the CSV file in the form of a data frame. As you can see here, a very similar information that we had in this list, name of countries, cars per cap, which is cars per 1,000 people, and whether the people drive on the right side of the road, are stored in this cars.csv. Instead of reading them from a list and creating a data frame from a dictionary, now we are just directly reading those information from a CSV file and directly putting it inside the data frame. Another thing that we can note here is this first row. By default, this read underscore CSV would read the first row as the header. And this is something you don't like, right? Because this is also one of the rows of your data. You want that to be index 0 and then push this data one index or one row down, right? So in order to do so, you have to read CSV file, but you also have to mention something else. So you have to read the CSV and you have to tell the pandas read CSV that you want the first row not to be considered as header. For that, you have to set header as none. Otherwise, the first row would be set as header. If you do so, then carsDF would look like something this. So it would just put some numbers instead of columns. And now this row, which is actual data, would be the first row in your data frame. Now, you may also want to set some headers, right? Because right now, if you look into the data frame that you have, you want these columns to have a more meaningful name. Let's first extract the headers of this data frame. If you do cars underscore df button and then click tab, you would see a lot of information that you can do here. One of them is that you may want to see the columns names. If you do so, it would tell you that columns right now, they just have a number associated with them, right? 0, 1, 2, 3, 4, meaning that there is no specific column name associated with each column. So if you want to rename the headers, you have to do the following. You have to do cars underscore df dot columns. And now this time, instead of printing them, you can set the values that you are looking for. So you can start setting the name of the columns, and that would get assigned in the order that is appear here. So that would be, the first one is the country code. The second column is region. The third is country name or country. Third is the car per cap or capita that we were familiar with from example 1. And you can name the last column, the Boolean column, right underscore drive underscore right. Now, if you do so, and let's just print the data frame again to see if this has been executed. Yeah, so it looks like a slightly nicer data frame because now you have assigned meaningful names to the columns: country code, region, country, car per cap, and cars per cap, and then drive underscore right for this Boolean column, right? Okay, so far we have read a data frame from a CSV file and renamed its columns. So far we've been able to extract the column names and set the desired column names. Now let's look into the row index or names. These are the row indexes that are currently set. So this is row index 0, row index 1, and so on and so forth. So if I type cars underscore df dot index, it's going to tell me that the range index starts from 0, stops at 8 with the step of 1. These are my indices. When reading a data frame using read underscore CSV from a CSV file, you not only can set the header, but you can also set the index. So if I want to set the first column as index, and this is the first column, right? So if you open the cars.csv, this is the first column that you would see. There's no such column in there, right? So if you want to set this column, which is the first column in the CSV file, as the index, and skip the first row and not set that one as header, we learned that we have to do header none to skip the first row and not set that one as header. And if we want to set the first column as index, we have to do index call equal 0. So when I run this, because of header equal none, I can see that the first row is not set as header, so that's good. The second thing I can see here compared to here is that there's no such column as 0, 1, 2, 3. Instead, the first column is set as the index. And technically, this country code is no longer a column here, right? I still have region, country, cars per cap, and drive right. But this country code, which was the first column in the CSV file, is now the index. So if I want to set the column like I did before, I can use a very similar piece of code, but there's no such column, right? Actually, there are 4 columns to be more accurate. There is region, country, cars per cap, and drive right. And this is now an index. So there's no such column as country code. It's now an index because we have set the first column to be indexed by setting index underscore call equal to 0. So if I do this and run this again, and run this again, and okay, I have to put this here now. Now I can see that, first of all, well, obviously the first column is set as index. Because of header none, the first row is not set as header, and because of this line of code, I have renamed the columns from 0, 1, 2, 3 to region, country, cars per cap, and drive right. I can even ask the code to, I can even print the index using, underscore that index and compare it to what I got before. When I run this, I can see that, okay, now at this point, I have these as my index, right? So my indices are no longer 0 to 8. My indices are USCA, ACPAC, and so on and so forth, which are the first column in my CSV file, and because of this, they are now set as index. Okay, so we've been able so far to read a CSV file into a data frame, rename the columns, and even set the index as any column that we want, mostly as the first column. Here, we're setting column 0 to be the index. We can set other columns as well. We can rename an index name if we want, right? So just let's assume that we want the index name to be country code, right? So in cars df, if I hit here, I can in the cars df, you see I have a lot of methods and attributes to access. If I do index dot name equal to, let's say, country code, and print the data frame once again. So we have done a very simple thing. We just have renamed the index column, right? It used to be 0, just 0 here, right? So by this, we set the first column to be index. With this, we just have assigned the name that we wanted to be the name of the index. So we rename the index name by country code and by doing. To delete the index name, depending on your Pandas version, you may need to use del function, or for the versions, like latest versions, this is what you have to do. You have to do cars underscore df dot index dot name equal none, and let's just print it to make sure that we have deleted the index name. When I run this, the country code is no longer the index name. There's no index name because we have just set it to none. Everything else in the data frame remains the same. So that's deleting the index name, renaming the index name, and some other manipulations to the index name. We can even set a hierarchical index. So let me just read the cars.csv file again and put it into the data frame. This is what we've been doing so far. and set the column's name like we did in the very beginning of this lecture. Okay, so what we've done so far is that we just read the data frame, skip the first row, and set it not to be the header, which is what we wanted. And now we want to set the index to be hierarchical. Previously, we just did index underscore call equals 0, which would set the first column as index. But if you want to do more columns, this is what you have to do. You have to use this function called cars. So you have to first type the name of the data frame and then call this set underscore index function. Inside the parentheses, you have to first assign the set of the columns that you want it to be the index, because you were looking to do a kind of a hierarchical set indexing. Let's assume that we want to do region and country code in the following order. We want to do region first, and then you want to do the column country code. Okay, this is the hierarchical that you want to use for your setting of the index, and you have to do in place equal true for that matter. Let me run this and print the content of cars underscore df data frame. So basically now you have two index in a sort of a hierarchical indexing, first indexing on region and then on the country code. And now you have only 3 columns, right? So from the initial 5 columns, we have dedicated 2 of them to be our index in this order, first being the region and then second the country code. The rest of the information is just the same. You have again country, cars per cap, and drives right as the actual columns, and our rows are also the same. Finally, we may want to write back everything that we have done to this data frame into the CSV file. So there are situations in which you either create a data frame from the raw data stored in a dictionary, or you may just read it like we did in this lecture from a CSV file. You manipulate it, you make some changes, and you want to write it back to a CSV file, because the CSV file is what you can send back to your customer and a real person who has nothing to do with Python. So this is a very common application in which you want to just write a data frame to a CSV file. Kind of the opposite of what we did with read underscore CSV. Here we were reading from a CSV file to a data frame. Now we are writing a data frame back to a CSV file. So in order to do so, you have to type the name of the data frame. Now the function would be to underscore CSV, and this is just the name of the CSV file that I'm just picking a different name. The initial file was cars.csv. Now I'm choosing a different name. Maybe I just want to keep the original copy. This is how you would write a data frame to a CSV file. Okay. So this is what so far we've learned on data frames. We have learned on how to we have learned on how to create a data frame from a couple of lists in a sort of a raw data stored in a dictionary in the first part of the lecture. We also learned how to read a data frame from a CSV file. Basically, we read the CSV file and put it inside a data frame. And we learned how to manipulate rows and columns, mostly the header column and the indexes for now. And ultimately, how to write back a data frame into a CSV file. These are a very common and typical things that a data scientist would do in his or her normal daily job. I'm doing that all the time. I'm reading a data frame. I'm reading a CSV file into a data frame, doing some manipulation, some operation on top of that, adding rows or removing rows, which we'll get to learn those as well. And then ultimately, I'm going to write that data frame back to a CSV file and send it to the parties of interest. Now that we are able to read a CSV file into data frames, it's time to look into more details with a case study. Here we have sales data given to us in a data frame called sales.xlsx. Let's start reading that file into a data frame and see how it looks like and do a few things on that data frame. So I'm gonna call the data frame to be sales, the name of the data frame to be sales. Let's use the Panda, and this time we have to read from an Excel file. So instead of read underscore CSV, instead of using read underscore CSV, we are going to use read underscore Excel, and then the name of the file, which is sales.xlsx. Let's run this, see how it looks like. So that data has its own header from the Excel file. So if you look into the Excel file, you have the header's name. So this is in addition to what we had in the cars.csv file. So we don't need to set header none. Actually, we have the header from the CSV file or from the Excel file. We have the header from the Excel file and we can use it here. So the data has 23 rows. It has 1, 2, 3, 4, and 5 columns. The first column is market, looks like the continent, region, number of orders, profit, and sales. The beauty of reading files using Pandas is that you don't even need to look into the Excel file or CSV file most of the time, and just reading them directly into a data frame gives you all you want. Now let's do a couple of things here. Let's set the first 2 columns as index. So instead of reading it like this plain, we are going to set the first 2 columns as index. So index underscore call is now 0 and 1. And let's see how it looks like. When you do so, it does something very beautiful. This is the so-called hierarchical indexing that we talked about in the previous lecture. It clubs all the, so it indexes by column 0 and 1. And remember, the first column was market, the second column was region. So it kind of clubs all the data that has the same market as Africa and then put them into regions, different regions that they have. And then the rest of the data is as it is. So if you look into this data, and let's assume that they were in different rows. Now all the Africas are also happens to be in the rows from 0 to 4. All the Asia Pacifics are from row 5 to row 10, and so on and so forth. But even if they were in different rows, not necessarily all the Africas all clubbed together, they would have been clubbed together using this hierarchical indexing by column 0 and then column 1. So this is just the same data, but set the index to be the first 2 columns in this order, right? So instead of repeating Africa for a couple of times, it would just tell you that because you told me to index by the first and then second column, I'm just gonna not repeat Africa, and you would definitely understood that, well, the rest of these 1, 2, 3, 4, 5 rows are of the same market, Africa. So this is the beauty of this index call if you want to group and club stuff together. So now you have a picture of this data. Another thing that you can do is that in most of these cases, you may just look into the few first rows, right? So in most of these scenarios, you may want to just look into the top rows. So if you just want to look into the top rows, all you have to do is to just type sales.head and then parentheses. That would just only print the first 5 rows of the data frame for you. So I'm going to just put this here. This is the default, right? So it would print the first 5 rows of this data frame for you. If you want more rows to be printed or less rows to be printed, let's say you want to, the first 7 rows to be printed or 3 rows to be printed. So you just have to mention the number. The default number is again 5. So if you want to, as the example was asking us to display the first 3 rows, you just have to do sales.head3. If you want to print the last 3 rows, you can use the so-called tails function here, right? So tail function again would print the bottom 5 row unless you mention the number explicitly. That would then print the bottom 3 rows for you, right? So in most of the scenarios, the data frame is very big. Here we only have 23 or 4 rows, which you can just print all of them in one screen. But in most of the scenarios, you have a data frame with millions and tens of millions of the rows. So you may just want to sneak peek, take a look at the top rows and bottom rows, just to get an idea that, okay, this is the data that has been given to me. This is playing just the role of opening an Excel file or a CSV file on your monitor and taking a look at it. You can do that without even doing so, just doing it in a Jupyter notebook. Now that you have seen the head and the tail of the data frame, you can also get more information from this data frame using the couple of functions that we are going to introduce. The first one is the info function. So you have the name of the data frame, and then you do info parentheses. This is going to give you an information, kind of a summary of this data frame. It is telling you that you have 23 entries. The data is multi-index because you have chosen the index column to be column 0 and 1 to be index, right? So that's the thing that we have chosen with this line of code here. We wanted the market and the region to be indices. They are no longer actual columns, they're indices. That's why you have multi-index here. 23 entries are referring that the 23 rows that we have. And these are our indices, right? So our indices are now, we have 2 indices in a hierarchical fashion. So these are our indices. It's telling us that you have this index, this pair kind of tuple of index to this tuple. The other thing that it's telling us is that it's going through all of the columns now. So these are the data columns. So as you can see, it doesn't see the indices as the data, right? The columns are the actual data. We have total of 3 columns, the number of orders, profit, and sales. The number of orders, profit, and sales. And there are 23 rows again of all of this. Number of orders is stored in the form of an integer, 64. Profit and sales are floating numbers. And this is telling us that this is the amount of memory used by this data frame. It's kind of just computing all of this and summing all. It's kind of adding up all of these memories and give us this number of 932 bytes. So this is one type of information that you can get. Another type of information is the so-called statistical information that you can get. So if you do sales.describe parentheses, it will give you a different type of data, a statistical information. So this would just go through all the columns and give us the count, mean, average mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and the max of the data. So let's just focus on this column. It's telling us that you have the number of orders are 23. So that's actually the number of rows that we have. So we have 23 orders, 23 number of orders, right? So that's actually this column. It's telling us that this data count is 23. That we already knew, kind of. But it's now giving us more information. It's telling us that the number of orders average is 366.47. The standard deviation is 246. The minimum number of orders is 37. The maximum number of orders is 964, right? So if you want a statistical summary of the data, describe is your best friend here, without going through any other functions or code. That you can just run this line of code on your data frame, which is extracted from the CSV file. You can provide a very good input to the parties of interest or to yourself that, okay, this data has, what is the count of this data, what's the average, minimum and maximum. Regarding this 25 percentile and 50 percentile and 75 percentile, this means that the minimum here again is 37 and 25% of this data, which is 25% of the 23 rows that we have, are below 211.5. 50% of the data is below 356, 75% is below 479, and all of the data is below 964. That's what makes 964 the max of data. Same logic and same explanation holds for profit and sales. You can go through it, even double check if mean or max is correct and that kind of data by even opening the Excel file. But that's just to give you the idea that you can use the scribe function and get all of this information in one shot. So from a statistic, you should be slightly familiar with the concept of box plots, but I'm gonna just draw some of those for you. So let's say we want to look into sales and profit, these two columns, right? We want to look into profits and sales, and we want to kind of plot them in a box plot form or fashion. So this is what we want to do. We want to plot sales and profit from the sales data frame, right? So actually, let's start from the left side. So from the sales data frame, you are interested in the sales column and the profit column. And you want a box plot. So you want to plot them, but the kind of a plot you are interested in is box. And because you have both sales and profit, and because you want to plot both sales and profit, you're setting the subplot to true, meaning that you want one plot for sales and one plot for profit. Ultimately, you have to do just plot that show. We'll get to these plot functions later on, but for now, let's just run this block of code and see what we get. So we get two box plot in the form of subplots, right? So this is the subplot corresponding to sales. This is the subplot corresponding to profit. So let's get to understand the notion of box plot and what these lines means with looking into sales data. So with the sales data, the last column on the right and the left box plot, the minimum of the sales is 81.90. That's about this line. So this black line and the bottom refers to the minimum. The first line here is the 25 percentile, which is 82,000 almost, right? So this is telling us that 25% of the data is below 82,000. The green line refers to the 50 percentile, which is 170, or this is so-called minimum. Half of the data is below this line and half of data is above this line. And again, this is different than average. It's just telling you that half of the data count-wise is below this green line and the rest of the half is above. This line is the 75 percentile, which is 290,000 almost. And this line is the maximum. What kind of makes it slightly, different than the actual maximum is that the box plot has this notion of outlier. So it looks into the data and based on some logics or heuristics, it may or may not detect some of the values in the data as outlier. So outliers simply are the data which are way above the average or way below the average. So there's this code inside this box plot that would detect some of the data as outliers, meaning that it would kind of sense that this data does not belong to the rest of the data, looking distribution-wise and mathematical-wise. Having done that, it would detect this max number as an outlier and kind of plotting it with a circle. Excluding this one, the actual max is somewhere around between 40,000 and 50,000. That's what this line is. So if you look into the profit where there's no outlier detected, the line here refers to the maximum, which is 82,000, right? So you can double check the profit box plot. This is minimum 25 percentile, 50 percentile, or median 75 percentile, and this is the max. And if any of these dots are plotted, they are referring to the outlier. You may look into outliers, but in the statistical course, we have a description of the outliers as well. Finally, you may just look into one column only, right? So you may just say sales. I'm just going to look and print all the values in profit column. If you do so, okay, it's detecting an error here. Yeah, I have to do capital P, right? So you have to put the exact name of the column. So this is the profit column, indexing by first the market, second by the region, and this is just the profit column. So actually one way to kind of double check here is that you can see that, okay, is the minimum really minus 16,000 in the profit? And yes, there are 3 negatives, and the smallest of the negatives is minus 60,000 approximately. So this is your way of looking into just one column, print them all in your screen, and just take a look. If the data size is small, but you can do that. Otherwise, your best friends are this describe, info, and maybe box plot if you are familiar with this notion. But just for the sake of a statistic, I would just encourage you to look into the notion of percentile. But to summarize again, 25 percentile refers to the fact that 25% of data is below this number, 50% of the data is below this number, 75% of data is below. These are kind of very important numbers in addition to mean, max, average, mean, standard deviation to describe a data in a statistic form or fashion. So with that, we have kind of looked into this sales CSV Excel file. We're able to print the header, head, tail, get the summary of the data that's been in there, and get a sense of some insight into the data as well as some visuals. In the previous 2 lectures, we learned about DataFrame. We learned how to create a data frame using raw data stored in a dictionary, or how to read file from CSV, or how to read data from CSV files and Excel files into a data frame. We also learned how to sneak peek into a data frame using head or tail functions, or how to get some summary or statistical information by using info and describe methods. In this part, by focusing on the same case study of sales data, we are going to learn about indexing. The purpose of indexing, as we've seen before on list and NumPy, is to access part of the data. Here we have rows and columns. So the purpose of indexing would be to access different columns or rows or a portion of this data. Let me begin by reading the CSV file or the Excel file into a data frame. So that would be sales equal pd read underscore Excel sales.xlsx, and just print the data frame. So as you can see, this is the same data we've been studying since the previous lecture. It has 5 columns in the Excel file: market, region, number of orders, profit, and sales. Now let's read the same file, but now setting the second column as index. We also learned that we can do that by adding an input to the read Excel file, which is index underscore call equal to 1. Second column would be index call 1. If I do so, then I would actually see 4 data columns, and now region, which was the second column, becomes the index. So we have index by region, and kind of take the rest of the 4 columns as the actual columns here. So far we have read this Excel file, set the second column as index, and put it inside the sales data frame data. Now let's start by column indexing. As mentioned, the purpose of column indexing is to access specific column. So in the sales data frame, if you go, so in the sales data frame, if you use square brackets and inside double quotations or quotations, mention the name of the column that you want, and then run this block of code, it would give you the sales column. So here you can see the sales number, and because the region now is your index, it would also type each region. So these are all the rows with only sales column left, because you were trying to access or index the sales column, right? So this is how you would access a column. Another way of accessing a column is to do sales and using the dot operator and the name of the column here, now without double quotations, but the exact name of the column. If you do so, that would print the same thing for you. So far, we've been able to access a specific column. Now let's just take a look at the type of this column, data type. We want to know what is the type of sales inside the square bracket, capital S, sales. So this is the so-called Panda series. It's another type of Pandas data type. So we've been familiar with DataFrame mostly. Series and DataFrames are two data types under Pandas. And as you can see, if you filter out a specific column or index a specific column, the data type would be Panda series. You can ignore these for now, but mostly the data type here is Pandas series, which we will be working with. But just to know that, okay, once you filter out or index a specific column, you would get a data type which is series. The reason that it's not a list, right? Because, or a NumPy array, you have two. You still have two type of data altogether. One is the index, and the other one is the actual column or the values you're looking for. Because of that, it's not a typical NumPy array or list. It's a Panda series data type. Now let's try to access or index multiple columns together. We've seen how to index one column, and now the goal here is to index sales and profit columns together. In order to do so, you have to type the name of the data frame, square bracket, and because you are indexing more than one column, you need another square bracket inside which you would type the name of the columns you're interested in sales and profit. So in a way, you are giving a list of columns inside square bracket, right? This is a list data type. Once you do so, you have the index, sales and profit column. And remember, region is no longer technically a column, it's an index. That's why you have it all along with the actual data and the column sales and profit. So here we are indexing or displaying two columns at a time. This is about column indexing and accessing specific columns. In order to index a specific row and even a specific column, we have to use a method called LOC, short for location, or the so-called lock accessor. So again, you have to type the name of the data frame, dot operator, and then LOC. And inside the square bracket, mention the index that you want to access. You want to access Southern Asia, and you know that Southern Asia is one of the indices. So just do this, click the hit button, and you would get the row with the Southern Asia index. So if I go back to the actual data with the 23 rows, there is one row with region Southern Asia, right? The market is Asia Pacific, and this later on becomes our index, right? So let me go to the one with the index region. So there's one row with Southern Asia as the index or region, and we know from this point downwards, region is our index. So this is the only row with index Southern Asia. The market is Asia Pacific, 469 orders, and this is the profit and the sales. We get the same data here. 469 number of orders, profit and sales. You can double check above, but this is your basically row with the index Southern Asia. You may also display sales data for the Southern Asia, right? So within the Southern Asia index, you're interested only in the sales. So basically you're interested only in this number. You can still use the lock accessor to do so. So that would be sales.lock, square brackets. And now you're kind of doing a two-dimension, right? You first go to specific row, which is the Southern Asia, right? That's the row or the index. Within that row, you are interested in a specific column. So it's a 2D indexing or accessing a 2D point, right? So you need two indicator. One of them is the index or the row, and the second one is the column, right? So here you can mention both of them. That would just spit out for you the sales value for the Southern Asia region, which is 351,000 and change. So with LOC accessor, you can not only access specific row index, you can also access specific column index, and you can also access a data point within that data frame, right? So we have done both of them here. So with the lock accessor, we were using the index name for row and or column to access that specific row index and column index. If we use row number and column number, we have another function which is called ilock accessor. So remember here, when you are talking about numbers, this is column number 0, column 1, 2, and 3, and these are the row numbers, right? So let's assume that we want to access Southern Asia, which is basically 0, 1, 2, 3, 4, 5, and 6. Okay, so we can do name of the data frame dot ilock. Now that's just doing, we are trying to do the same thing as we've done in block 14, but with the row number. So we have to do 6. When we run this, we get the exact same data. Basically, we are indexing that specific row, either through the index row index, which is Southern Asia, and lock accessor, or through the row number and the ilock accessor. If you want to do a similar thing like accessing Southern Asia and the sales, with ilock, we have to do sales.ilock. It's a 2D accessing, right? So we have to go to the 6th row and then 4th column, which would give us 3, right? So that would give us that 351,000 for the sales. So we have seen two different types of indexing, either through the row and column index and the lock accessor, or through the row and column number and using ilock accessor. Now let's go to slicing. As you remember from the list and NumPy, slicing is basically indexing a chunk of rows or columns, right? So with indexing, you would access specific row or column. With slicing, you would access a range of rows or columns. Let's assume that we want to display data for market, sales, and profit. These are the columns, right? So going back here, market, sales, and profit are the columns. So the goal here is to slice out these columns and obviously all the rows for these columns, right? Because it has nothing to do it doesn't mention anything about rows here. It says display the data for market, sales, and profit. And from the initial data, we know that these are columns. In order to do so, you have to do sales dot, you can use lock, and you want all the rows, so that column is for all the rows, and you want a subset or a slice of columns. So you want market, you want sales, and you want profit in the order that you are interested in. If you do so, you are going to get the entire rows with only 3 of the columns that you have mentioned. Instead, you may also want to just do head here and, get the 5 top rows. But basically what we have done here is the so-called slicing. We are slicing 3 columns. Remember, we had 4 columns, excluding the index. And we want all the rows. So here's how we would slice. This is the list of the columns we are interested in. We can also use iloc to do the same thing. So with iloc, you still want all the rows. So you're going to use column here for all the rows. You want market, sales, and profit. If you go up there, market, sales, and profit are column 0, 3, and 2, right? This is the order you want. You want market, sales, and profit. Column 0, this is no longer a column, it's an index. Column 0, column 3, and column 2. So you just refer to the number 0, 3, and 2. And let's just do the head to get a smaller print so that we can compare with the block above. It's going to give you the exact same thing you would have done with lock and the column names, now with the column numbers. So now you can appreciate and understand the difference between lock and iloc. You can do almost exact same things that you have done with lock through iloc. Instead of row indices and column names or column indices, you need row numbers and column numbers when you are using iloc. Okay. Now let's do some more exercises here. We want to display data for Western Africa, Southern Africa, and North Africa, right? These are indices. Western Africa, Southern Africa, and North Africa. So here you want specific rows, but all the columns, right? So kind of different from the data that you have done here. So this was slicing on columns and all the rows, keeping all the rows. This is slicing on rows and keeping all the columns. So again, you can use either lock or iloc. Let's do both here. So that would be sales.lock. So you want all the columns. That's for all the columns. Now let's pick the rows. So you have to provide a list of the rows that you're interested in. You're interested in Western Africa. You are interested in Southern Africa. And you are interested in North Africa, right? So this is the slice of the rows that you are interested in, and columns, you want all the columns. So let's just do, this is just 3 rows, so you don't need head here actually. So you need, that's basically what you've been asking for. We've been asking for 3 rows indexed by Western Africa, Southern Africa, and North Africa. And you want all the columns basically, so that's what's been given through lock. Obviously, you could have used iloc and point to rows from 0 to 3 and all the columns. This is kind of a 2D slicing through numbers because you're using iloc. So it's a 2D slicing, row 0 to 3, excluding 3 and all the columns. That should give you the same exact slice of the data frame, but now through iloc. So in the 2 previous examples, we either sliced on rows or we sliced on the columns. We can do simultaneous slicing on both rows and columns. So here we want to display sales and profit, which are 2 columns out of the 4 columns, for Western Africa, Southern Africa, and North Africa. So this basically is slicing on 2 dimensions, both columns and rows. So we can do the following. We can do sales.log and go for Western Africa, Southern Africa, and North Africa. But we don't want all the column. We want only sales and profit data. So that's the chunk of the data frame that we are interested in. Only 3 rows and only 2 columns. Obviously, again, we can do the same thing with ilog. We just need to know the columns and rows number. So that would be rows from 0 to 3 and columns 2 to 4. You can see the same data. So we've been using so far and kind of get familiar with the log and ilog to slice or access and index portion of the data frame that we are interested in. The other scenario that is also very common is that you may want to look at a specific part of the data conditioning on something, right? So in the case study that we have at hand, maybe we want to look at the market with sales larger than 300K, right? So let's take a look at the data again. Up here, we have the data, regions and all the columns, and then we have this sales number. So we are only interested in sales larger than 300K, and we want to see how does that data look like. Now let's say you want to display only Latin American and European countries with sales larger than 250,000, right? So among the regions, you had different regions, and of course different sales and profit, right? So here the example wanted us to only display these countries, or specifically these regions, where the sales is larger than 250,000. So in a way, you are checking 2 conditions. The first condition is, or the second condition is on the sales, like the one above. The first condition, or the first statement, is also a condition. You only want these countries. Okay, let's get to writing this. So you want sales data, obviously. And here you have to put 2 conditions. In most of the programming languages, you can use logical operators, which we are familiar with, to do and, or other type of logical operations. You want and because you want both of these conditions to be satisfied. The second condition is kind of what we've been doing before. We want the sales to be larger this time than 250,000. So that's our second condition. Now let's get to our first condition. In our first condition, we want the market to be Latin America and European. Let's take a look at the data again. So when you look at the data, the market is Africa, Asia Pacific, Europe, Latin America, and USCA, which is basically Canada and different regions of US. So your second condition, or your first condition, however you want to look at it, is on the sales market. You want market column value to be either Latin America or European. So for that, we are using a membership check in our first condition. We want to make sure that sales market column is in our list, which is either Latin America or Europe. So let me just put some spaces to make things clear. This first is just the square bracket. You have first condition, which is going to check that only rows printed where the market is either Latin America or Europe. You have a second condition which checks the sales and only print the sales that are larger than 250,000. You have an AND logical operator that would only print rows and columns that satisfy both of these conditions. If I run this, I'm going to get 3 rows. And as you can see, within these 3 rows, sales is definitely larger than 250,000 and the market is either Europe or Latin America. So if you go back to the data, you can see that you have a lot of rows, 1, 2, 3, 4 with Europe and 3 rows in Latin America. But not all of them have sales larger than 250,000. Those printed here are the subset of those rows for which the sales is larger than 250,000. Most complicated things that you can do with DataFrames. It's actually very useful for the scenarios in which you have a condition in mind. It might be a combination of 2 logics or 3 logics. You see, you can add ands or ors here inside the square bracket, the outer square bracket. You can add as many conditions as you want. Some of the conditions are imposing a condition on rows or applying a condition on columns. That's the beauty of this type of slicing that we do. This is just comparing against a number. This is comparing the market to be within one of these 2 values. So it looks at the market. If it's either Latin America or Europe, that would be a true condition. Otherwise, it's a false condition. So far, we have learned how to read an Excel file or a CS file into a data frame and do some basic operations on that data frame. Operations such as reading the first few lines, header, tail of that data frame, indexing specific column or a specific rows, slicing that, and also doing the same things with the conditions. In this part of the lecture, we are going to work on those operations in a new example, and also we are trying to learn and apply more operations on the data frame. Let's start by introducing a new example. A company in Australia found that the sales for their best-selling items are heavily affected by weather and rainfall. So, for instance, they found out that the sale of tea increases if it rains, or on the other hand, when there is no rain and the sky is clear, they may start selling more of the sunscreens. This is a very common pattern for every e-commerce platform. So they start to check the weather pattern because that would play an important role in their sale for certain items. So in the initial experimentation, they would like to forecast the weather trend in the upcoming days. So the target, again, is in Australia, and we are trying to analyze the data, the weather data that we get from the Australia region. The data comes in terms of a CSV file, so let's begin reading that Excel file. The Excel file name is weatherdata.csv, so it's a CSV file. Let's start reading that CSV file and try looking into the data using the Pandas library. So I'm going to import the library as PD, as we've done in the past. And I'm going to read this CSV file. So weatherdata.csv, I'm going to read this CSV, put that in the data frame, and then later on look at it. Let's display the data header. So when I do so, I can see that I have a lot of information in that data frame. I have columns with respect to location, minimum temperature, maximum temperature, rainfall, whether there is an evaporation or sunshine, and the wind gust direction and speed. Some of the data may not be available. That's why I have NaN values. We will get to that later. And there's also this column with respect to the data. So this is a timestamp data. And also technically it's a time series data. A time series data is a type of data that you would not only score a value like temperature or wind gust speed, but you also store the corresponding time or date stamp with that. That is what we refer to as a time series data. As you can see here on the very first column, date, you have the day like December 1st, 2008, December 2nd, 2008, and so on and so forth. So this is what we technically call as a time series data. So if you see somewhere they're talking about time series data, this is one form of a time series data. Here, you not only have date, but you also have a lot of other information, locations, temperature, rainfall, and so on and so forth. So here, again, that information is repeated. The date, location, and temperature, and all of that is explained and their corresponding unit. Now let's start by filtering this data frame. In the first example, we are trying to find the days which had sunshine for more than 4 hours. These days will have increased sales of sunscreen as explained in the introduction. Let's start by looking at that. So remember, by putting the name of the column in the square bracket, you would have access to the entire data frame. And as you can see, a lot of values are not available or not defined. If you want more than 4 hours, because the sunshine here, so one thing that is explained here is that the column sunshine refers to the number of hours of bright sunshine in the day. So if you do so, then you get a Boolean time series data. Remember, we talked about the fact that if once you access a column by putting the name of that column in the square bracket, you technically are creating a Pandas series data type. By putting that condition, you would get a Pandas series Boolean data type in which the column, the values of each row are either false or true based on the fact that whether they satisfy this condition or not. If you want to really access that data, meaning you want to get to the data where this condition is satisfied, you need to put this conditional operation or conditional statement inside the square bracket and again index that. So if I run this block of code, I'm gonna get the rows of this data frame for which this condition is satisfied. So again, we talked about this in the previous lectures, but it's good to emphasize and repeat that this is what we refer to as filtering the data frame. So if there is a specific condition in mind that you would like to filter the data frame based on that condition, this is how you would do that. You put the conditional statement inside the square bracket and again print the name of the data frame here. Type the name of the data frame here. So this would give you a subset of this data frame for which this condition is satisfied. So these are all the rows for which there are more than 4 hours of sunshine. As you can see, at least for the head and tail here, you can see that they all have more than 4 hours. Let me just do one thing so that we can see that this is a subset of that. This is a subset of that data frame. If I do data shape, it's going to tell me that I have this is a relatively larger data set compared to the previous example. You have a data with 142K, with approximately 142K rows and 9 columns. When I filter on having the sunshine more than 4 hours, I'll get a subset of this data frame with the same number of columns, obviously, but with around 59K approximately of rows. So of that data, only these numbers satisfy this condition. Also, if you look closer into this subset of data frame where the sunshine happens more than 4 hours a day, you can see that there is relatively low rainfall, which kind of makes sense. Okay. So this is how you would, again, as we've seen in the previous lectures, how you would filter a data frame when you have a condition at hand. So another example on that same data frame would be the cold drinks sales will most likely increase on the day which have sunshine more than 5 and high max temperature more than 35. This is a condition where the company found out or assumes that the cold drink sales will increase. So let's use the filter operation to filter out those days and take a look at the data. So we again want to access to the rows based on a certain condition, right? So this is where we would put the condition in a pseudocode fashion, right? But right now we have two conditions, right? Previously we only had one condition. This was our only condition, sunshine more than 4 hours, right? So now we have another condition which we want both of those conditions to be satisfied. And obviously they have to be both satisfied, so we need to use the AND operand because we want both sunshine to be now this time more than 5. So let me change this 4 to 5. And we want the max temperature, which we have access to that data, to be also more than 35. So let me add another condition right here. The condition here would be that we want the temperature, the max temperature, to be more than 35, to be more than 35. And let me just, if I run this, I'm gonna get probably an error. I have too many parentheses that are not matched. I need to remove this and run this again. Okay, so as you can see, if I do this, I would get lesser rows, right? Because I'm imposing more and more conditions. I'm getting only 3,800 rows approximately, because these are the rows that have more than 5 hours of sunshine a day, and the max temperature is also more than 35. The company assumes that, or at least it has this comprehension that the cold drink sales would most likely increase in those dates. So again, apart from the use case, in order for you to apply such a filtering, kind of multi-condition filtering, you need to have each condition in the parentheses and separate them by the appropriate logical operator. If you want all of the conditions to be satisfied at a time, you need AND. If you want to do like one or the other, you probably better with OR operand. So again, this is how you would filter data frames. Now let's move to the other operation that we most likely want to do. As I said, there are some situations that you not only want to filter the data, but you want to create new column and put some new information there. This is where you may want to tell your customer or your manager or your other party that, okay, based on the data frame or based on the CSV file that they gave you, this is the output that you are kind of outputting or demonstrating to them. Also, if you notice in the filtering that we did in this example, these dates, they have, they're only simple dates, right? They are not split into month, year, or the day of the month. They are simply the dates. So one thing that we want to do is that we want to extract day, month, and year from that date column using the so-called date time index module that we have access to. So Pandas will give you that date time index module that is capable of extracting these year, month, and date out of this date column. Let's start working on that. Under Pandas, there's this so-called date time index where you can input that column, right? So the name of the data frame was data. So I can input here the column corresponding to date. Let's see what I get. I get a lot of data, right? So if I just at this point, if I just input the date column, it would just print me all of that 142 cache dates in form of a date time index data type. So this is a data type under Pandas library. What I'm mostly interested is dissection of that into year, month, and day of the month. So if I do year, because that date time index is prepared to do so, it would only give me the year out of those data. So it's giving me 2000. If I go back to the original data, we have a lot of 2008 here, and it's giving me all of the years only, right? So this date time index can take date type columns, and then if you specific year, month, or day of the month, it would then spit out only years or whatever you were asking it to do so. So this date time index again is a particular module under Pandas DataFrame, which has this capability of extracting smaller components of that data. Okay, the goal was to add new columns, right? I wanted to add a column called year. So this is a new column where I'm adding to this data frame. And I want this to be just a year, right? So that's the thing that you have to pass here. So basically, with doing this, you're adding a column which is kind of created from another column you already have. You have this column, you would pass this column to this date time index module and ask this to only extract the year component out. The input to the date time index is the column date of the original data frame. So let me do so, and let me take a look at the header of this data frame. I'm now seeing this new column almost all the way to the end because you have not specified a specific location for that. So it would create a new data frame with only the years, and the years are just coming out of this date column, right? So it's not coming from anywhere outside of the data that we have at hand. So this is how you would create new columns. We've also done this in the past. This is just a repetition and an emphasize that because this is a very important thing for you to do, adding new columns, it's better on exercising in different form or fashions. So we have created a new column called year using this date time index module. Let's repeat this for month and day. So I'm going to create another column, month. And the more we go into this exercise, the more you appreciate the importance of both filtering and creating new columns. Because let's say you only want to look at years, only want to look at month. And again, this date time index has this capability of getting this input and only spitting out the month. And let's create day of month, right? So I'm just going to create a new column. I'm going to name this day of month, and this is going to be day. So let's take a look again at the header, and this time let's take a look at 20 rows, the first 20 rows of this data. So I have, I have not run this block of code yet. It's there, but it's not run. When there is no number here, it's an indicator that this block of code is not yet executed. So when I run this, I can see that the 3 new columns are there, and I can simply double check that year is 2008, month is 12 or December, and this is the first day of the month. All the way, there are 20 rows for you to double check that. You can change this number to get a print of more rows from the beginning or any location that you're interested in. So you have created 3 new columns using date time index, which would basically give you date of the month, and the year. Now let's exercise more and create another new column by taking the temperature in Celsius, because the temperature given to you in this data is in Celsius, right? The max temp and min temp are in Celsius. and you may want to be interested in converting it into Fahrenheit and storing it in that data frame as a new column. In order to do so, let's create this new column, data, and call this max temp underscore f. So giving some meaningful names would also make the data more readable for the next person who is going to use your output. The input to that would be the max temp column. And mostly the columns that we create are coming as a function of a current existing columns, right? So you want to get this column max temp and convert it from Celsius to Fahrenheit. You need to do the following. So you multiply each row of that column by 9, divide it by 5, and then add a 32 to all of those values. Let's just run this and get the sneak peek to the head of this data frame. So you have created the fourth column, the fourth new column, in which the data is just simply the Fahrenheit version of the max temperature in Celsius. You can also use lambda functions to create new columns. And we are already familiar with the lambda function. So if the operation that you want to do on the existing columns is slightly more sophisticated that we have done so far, then you need lambda functions to create new columns. Here, in this converting the Celsius to Fahrenheit, the operation is relatively simple. You just wanted to multiply the existing column by value and then add a constant to that. But let's say we want to do something like this. Let's say we want to create a new column which highlights the day where we have rainfall more than 50 millimeter. If you remember, in the data header, we have the rainfall in millimeter, and we want to here add a new column which would only highlight those days for which we have more than 50 millimeter of rain, and the rest would be not highlighted. So if you want to do so, you need to use lambda, and you need to use the so-called apply module. So let's take a look again. We want this rainfall. Let's take a look at the rainfall column. So this is just a Pandas series, data series, that would print the rainfall for me, the rainfall column. I want to highlight the days where I have more than 50 millimeter of rain. In order to do so, here's what you have to do. You have to use data rainfall and then use the apply module. And here is where you have to define the so-called lambda function inside the parentheses. So you have to define a function using lambda, which you are already familiar with, inside the parentheses, and then apply that function to this column. As simple as that. How do you define such a function? You use lambda. You see that the word turns into a bold green. X just means that whatever you do here, apply it on the X. So we want to return rainy. Let's say we want to return a screen. Let's assume that you want to return a string called rainy if X is more than 50, and else return not rainy. So this is the syntax for using lambda to create a new function. This would print rainy or output rainy if the input to this function, which is this column, and X here, if X is larger than 50, this function would return rainy. Otherwise, it would return not rainy. By using this very simple line of code, you are defining a function that would take one number, and if that number is more than 50, it would return rainy, otherwise it would return not rainy. This function will be applied to this column. If I run this, I'm gonna get a new column with either rainy in the rows or not rainy in the rows. And obviously for this header and tail, you would see not rainy because most of these values that you can see in the top 5 rows and the top bottom rows, they are below 50. So we have created a new Panda series or like a column, but we have not technically attached this column to a data frame, right? So this is a tiny note to kind of note here, is that with this line of code, you have applied this function to this column. You have printed this Panda series, or which looks like a column, but you have not added this column as a new column to this data frame, right? So one thing to note here is that, let me just do that. If I do type of data rainfall, this is a Panda series. So in short, right, as we mentioned before, it's another type under Pandas library in addition to DataFrames. So this is a Panda series. Okay, right. So if I really want this line to create a new column and get it appended to the data frame at hand, I have to, like before, create a name for that, like is raining, and add this line of code here. So this would technically create a new column and add it to the data frame and name that column is raining. Let me run this and let me take a look at data header. So you can see that with this, the is raining will be added and starting with not rainy or rainy, right? Okay. Another thing to note here is that you could do this with the following syntax. You could simply do, is raining too, and instead of pointing to the current column inside the square bracket, you could have done this. You could have done dot rainfall. So another way to access the columns and then apply functions on top of them is use the dot operand and then the name of the column. So you either use dot rainfall or use square brackets, double quotes, and then rainfall. Let me just run this and get another head here. You see, we get same column with a new name. I just wanted to have this to another name so that to show you that this is another way of accessing a column, right? They're both doing the same thing. You can just, do either. And then later on, if you are really interested in rows more than 50 millimeter of rain, you can just do the following, right? So you have created a new frame. So you have created a new column, is underscore raining, that is either rainy or not rainy based on this 50 millimeter threshold, based on this 50 millimeter threshold. So if you do data and then do a conditional statement here like this, this time you want the rainy days only, right? So you just put rainy. You know beforehand that this column is either rainy or not rainy, and you know it is rainy if it has more than 50 millimeter of rain. So this is a conditional statement. If you put a conditional statement inside the square bracket, it is going to filter you the only 786 rows for which the rainfall is more than 50 millimeter. Out of that 140k rows, these are the only rows that we have more than 50 millimeters of rows. So we not only are able to print those rows, but we also have an indicator as a new column, which is either not rainy or rainy, right? So this is what I meant by filtering and creating a new column for the person who is going to use that data, right? At the end of the day, out of this data frame, you are going to create a new CSV file and then give it to your friend, manager, or your customer with the new columns. You can point to him that, okay, if you want days with more than 50 millimeters of rain, just look at this column. Just look at the is raining column. Okay, so with this, we have done a few examples in which we are able to create new columns. And most of these new columns are created by applying a function, a conditional functions most of the time, on one of the previously existing columns.